Hello everyone. Today I want to explain my homework 3.3 exercise 5.1. Let's focus on the homework content directly. Write HTML, CSS, and JavaScript to control LCD via mobile phone. The core objective of this homework are fourfold. First, use HTML, CSS, and JavaScript to build a mobile-friendly interactive interface that can set control commands. Understand how to use the a 2.io IoT platform for device connection and data transmission between the mobile interface and Node MCU. Achieve remote control of the LCDs on or off state through the network. Lets the LED respond to button taps on a mobile phone. Fourth, master the deployment of front-end application using Firebase, making the mobile interface accessible online. To complete this homework, I use three key tools, are directly related to the implementations Visual Studio Code, the main editor for writing HTML, CSS, JavaScript, and Node MCU's C++ code. It supports highlighting and real-time preview, which is essential for code development. Second is Autopilot.io, the IoT platform that acts as the bridge between the mobile interface and the Node MCU. It forwards commands from the front end to the hardware, enabling data communication. The third is Firebase, used to deploy the front-end code online. Without it, the mobile interface would only run logically, and remote control wouldn't be possible. Necessary for the physical control part, we use Node MCU v3 ESP8266 board, the crew control unit that connects to the network and controls the LED light, the controlled complete that lights up or turns off based on commands. Dual wires used to connect to LED resistor and Node MCU. 220 ohm resistor protects the LED and the Node MCU from excessive corrosive damage. Breadboard is in quick connection without solder, making it easy to assemble and adjust. The quick connection is the key part of the homework, with strict requirements for correctness. Correct two LEDs and long leg in serial with a 220 ohm resistor, then connect the other end of the resistor to the D0 pin on the node MCU. The resistor must be in serial. Omit it or connecting it incorrectly will damage the compass. Connect two LEDs short leg directly to the ground pin on the node MCU. This forms a complete circuit, allows the node MCU to control the LED via voltage changes. Auto.io configuration is mandatory for communication, and every step is turned to the homework code. First, log into Auto.io and create a sync device named IoT LED. This name must be identical to the one in the C++ and JavaScript code. Case sensitive C node tabs are allowed. Create a channel named test with the tab set to integrate this. This channel is used to transmit control commands. One for on, 0 for off, and the integrate tab ensures the node MCU can press the date correctly. Generate a key and copy it. This key is used for annotation in the code, ensuring only our homework project can access the device and the kernel. Incorrect configuration here will result in failed communication between the front end and the hardware. So it's a critical step in the homework. This is the HTML code. The HTML code builds the mobile interface structure, which is the user interaction layer of the homework. For example, line 5. Line 5. Make name, will port, contact, YDS device, YDS Intel screen is incentive for mobile adaptation. It ensures the interface fits for screens, a key requirement for mobile control. Line 22 and 23. Two buttons are defined, bound to turn on and turn off functions via one on click, not the tap in the button text. For example, turn off LED linked to the turn on, which I corrected later to avoid conference. And line 28. The status display area with ID is status shows the operation result. For example, turn on LED complete, allowing users to confirm if the command was set successfully. And line 36 links the JavaScript field, enabling the buttons to target actual functions. This is the access code. The line 16 to line 21. The EPN still sets buttons to 100 multiply 100px with spacing around them. This makes the buttons easy to tap on mobile phones, a key consideration for the homework's mobile control requirement. And line 1 to 6, the heading still centers the title with a dark background, improving reading ability. Line 7 to line 9, the counter limits the maximum width to 808px, ensuring the interface doesn't stretch excessively on large screen while fitting mobile devices, or still are designed to support the homework's crucial goals of mobile control. This is the JavaScript. Line 1, via HTTP is new XML HTTP request creates a HTTP request object, the tool for communication with A2.io. Turn on function line 4 to line 20. When the turn on LED between button is tapped, it sets a get request to N2.io API. The URL includes the key device name IoT LED, kernel name test, and command value 1. If the response is successful in cloud term, the status is updates. Turn on function line 23 to 37, simply to turn on, but sets a command value of 0 to turn off the LED. The URL permanence must match the A2.io configuration. Externally, any mistake here will cause to command to fail, which is a key checkpoint in the homework. This is the Arduino code. The code runs on the Node MCU and is responsible for receiving commands and controlling the LED, a crucial part of the homework. Line 4 to line 8, configuration variable include Wi-Fi, create A2.io user info key and device name. This must match the actual Wi-Fi and A2.io settings. Setup function line 12 to line 32 interlines the several ports. For debugging, connects to Wi-Fi and A2.io. Subscribes to the test kernel and sets the D0 pin and output. It also interlines D0 to high, turning off the LED interline. This is log function, line 35 to 37. Calls onto MQTT log repeatedly to maintain the A2.io connection. Without this, the Node MCU can't receive commands. Message received function line 41 to 60. the callback for receiving commands. It parsed the payload 1 or 0 and sets the D0 pin to low, on or high off. Accordingly, it also provides the command to the several monitor for debugging. This code is the link between the IoT platform and hardware, and its correctness directly determine if the LED can be controlled. This is fear-based development steps. Deployment is the final step to realize remote control, a required part of the homework. Install fear-based tools via npm install. G fear-based tools line 1. The log into fear-based line 3. Navigate to the project folder line 4 and run fear-based init line 5. Select hosting and set the public directory to public line 28. Choose no when asked to overwrite index.html line 30 to preserve the homework code. Run fear-based deploy line 1 to upload the front-end code. The deployed URL, for example, is this. Allows any mobile phone to access the interface. Deployment is managed because the homework requires remote control. Local code can't achieve this. The physical demonstration images show the homework's final effect. The circuit is correctly assembled with Node MCU LED resistor and breadboard connected as required. Tapping turn on LED on the mobile interface updates the stats to turn on LED complete and the LED lights up. Tapping turn off LED updates the status and turn off the LED. This result confirms that the homework's true requirement controlling LED via mobile phone has been fully achieved. To summarize, this homework focuses on using front-end code, HTML, CSS, JavaScript, and IoT platform No.3 and hardware Node MCU and cloud deployment fear-based to realize mobile remote control of LED. All steps from the code white to hardware connection and deployment are centered on homework's core objective. The key function, for example, turn on in JavaScript, message received in C++, and configuration onto .io's device, kernel key, hardware pins, and secretly implemented as required. The homework has been completed successfully. The mobile interface is functional, communication is smooth, the LED responds correctly to remote commands. Let's look at this video. Thanks for your listening. If you have any question about the code or implementation details, please feel free to ask. This is all my homework 3.3. Thanks for listening. Goodbye.